Imagine I walk right up to you in the street, totally out of the blue, and say, "Hey, my table is exactly 5 long." You'd probably look at me like I was crazy. You'd immediately have to ask, 5 what? Inches? Meters? Miles? A number on its own is, frankly, entirely meaningless without a physical anchor to tie it down.
And, well, that's the crucial point here, right? A unit is what breathes life into a number. It gives that raw data actual, tangible context in the physical world. It tells us whether we're talking about 5 meters of distance, 5 kilograms of mass, or 5 seconds of passing time. Basically, units act as the absolute translator between abstract math and reality.
So, welcome to this explainer. Today we're demystifying the International System of Units, which we all know as the SI system, and discovering exactly how it stepped in to bring absolute order to what was once a highly chaotic, fragmented world.
The quest for one system, overcoming measurement chaos.
Let's step back in time for just a second to see what actually happens when the world lacks a standardized way of measuring things. Imagine a scientist in India describing a table in their lab as 2 meters long. Meanwhile, a researcher halfway across the world insists that exact same table is 6.5 feet long. They are describing the exact same physical reality, but because they're speaking completely different measurement languages, their communication just totally breaks down. When you look at these older, conflicting systems, the historical headache becomes super obvious. You had the CGS system dealing in centimeters and grams, the FPS system leaning on feet and pounds, and the MKS system working with meters and kilograms. This totally fractured landscape highlights exactly why scientists desperately needed a single, unified system. The constant need for conversion wasn't just annoying, it was a massive liability prone to catastrophic errors.
7 basic Lego blocks, the foundation of measurement.
Enter the SI system, which brilliantly solves this historical communication crisis using a concept we all know and love. I want you to think of the SI system exactly like a brand new Lego set. Instead of thousands of unique, confusing pieces, you have exactly 7 basic foundational blocks. And here's the genius of it. By connecting just those 7 base blocks in different mathematical ways, we can build practically any other unit of measurement you can possibly imagine.
So here is the master blueprint. These are the 7 official base units established by the BIPM, the International Body Governing Weights and Measures. We have length measured in meters, mass in kilograms, time in seconds, temperature in Kelvin, electric current in amperes, luminous intensity in candelas, and the amount of substance in moles. These are the magnificent 7.
There's an incredible elegance to seeing all these concepts brought together, from spatial distance with the meter, to the flow of time in seconds, all the way to luminosity with the candela. They function as the absolute fundamental building blocks of all scientific communication. If you master these 7 concepts, you literally have the tools to decode the physical parameters of the universe.
A closer look at 4. Grounding theory in reality.
To really lock this in, let's grab just 4 of these specific blocks out of the box. We'll start with the meter. We all know what a meter is, but in the context of SI, it acts as the absolute gold standard for spatial reality. It's the unwavering anchor you rely on whenever you measure how long, tall, or wide a space or object is.
What makes the meter so powerful is its perfect scalability. You might naturally measure a pencil in centimeters, or map out the distance between 2 cities in kilometers. But the fundamental base unit underneath all of those measurements remains exactly the same: the meter. The prefixes centi and kilo are just mathematical modifiers that neatly scale that single base unit up or down. Next up is the kilogram. As the basic SI unit of mass, it functions as the universal baseline for physical matter. It directly answers one very fundamental question: how much physical stuff is actually occupying this space? And we use this base block every single day without even realizing we're tapping into a global standard. Whether you're buying 2 kilograms of apples at the market or hauling a heavy 5-kilogram bag of rice to stock your pantry, you're actively relying on this foundational SI unit to quantify matter. Then, of course, we have the measurement of time. Picture the tension of a 100-meter sprint on a track. The moment you hear the starter call out, "Ready, set, go," and you click your stopwatch, you're measuring the relentless passing of time. And in the SI system, you are officially doing it in seconds. Now, I want to pause on the number 60 for just a second, because it highlights a really fascinating quirk of how this system works. We are all deeply conditioned to know that 60 seconds make up a minute, right?
But in the strict architectural language of the SI system, the minute and the hour do not actually exist as base blocks. The foundational unit of time is solely the second. Everything else is just a construct built on top of it.
Finally, let's step away from visible objects and tangible mass and enter the invisible world of electricity. When electrical charge flows through a wire, we measure that current in amperes. You've definitely seen this expressed as a capital A printed right on the current ratings of your everyday devices and smartphone chargers. It's the invisible pulse of the modern world, perfectly quantified.
The global measurement language, unifying the world.
Okay, zooming back out from these specific individual units, let's look at the massive global impact of this unified system. Without SI, we'd be thrown right back into the dark ages of historical confusion. India engineering in meters, another nation strictly machining in feet, and yet another relying entirely on yards. Just imagine trying to manufacture a highly complex commercial airplane or a multi-billion-dollar space telescope with precision parts sourced from all three of those places. It would be a complete logistical nightmare.
So the overarching takeaway here is actually pretty profound. The SI system isn't just a boring list of rules you memorize for a high school physics test. It's deeply functional. It acts as the common universal language of measurement that allows scientists, engineers, and builders across the entire globe to actually talk to one another.
This shared language is literally the unseen engine driving international science, global technical development, modern industry, and everyday commerce. And to top it all off, its brilliant decimal structure, scaling perfectly in multiples of 10, makes converting between units incredibly fast and intuitive, totally eliminating the messy fractional math of older systems.
I'll leave you with this final thought as we wrap up this explainer. If humanity couldn't even agree on how to measure the basic length of a single table, how could we possibly hope to tackle the global engineering challenges of tomorrow? The SI system gives us the shared foundation to do exactly that. Keep exploring, keep measuring, and I'll catch you in the next explainer.